Okay, so what are the implications of this, that the 2 to the aleph naught is bigger than aleph naught?
So this means that we've more than one infinity.
Ah, okay, so one implication is there's more than one infinity. That's a huge surprise.
Mm-hmm.
There's more than one infinity.
And also, if it's just these, if we can make a larger infinity, we can make yet a larger one.
Ooh.
We can like do 2 to the aleph naught or something.
Well, yeah, we just found 2
Yeah.
to the aleph naught. So what's the next one we might find?
So 2 to the aleph naught?
2 to the 2 to the aleph naught. And so maybe there are infinitely many. Maybe there are infinitely many. Maybe we can just keep climbing up this ladder using the same argument with power sets. Did he use that word, power set?
I think so.
Okay. All right. And there's one other implication. I haven't read the book, so I wanted to go into this cold, so I haven't read the book. There's one other implication. I don't know if he mentioned it or not with these binary strings.
You can't ever find the largest infinity.
That's true. It seems like we can keep climbing up that tower. So that's an important implication. Do you know what these binary strings relate to?
Computers use them.
It's like the real numbers.
Okay, how might they relate to the real numbers?
Because you could take each binary string, and then you could make the real number. You could just add a 0 point,
Okay.
and then you could just make like 1. If you had the first number, you could do like that, yeah.
All right, and what is this set? If I made the set of all these binary strings, what numbers am I going to make? What real numbers am I going to make?
So, well, the largest real number you can make is 1/9.
Well, remember these are in binary.
Oh, these are in binary?
Yeah,
So this is going to be all the real numbers then from 0 to 1.
that's right. We can make all the real numbers from 0 to 1, and including 0 and 1. And so what does that mean?
So that means this set of real numbers. So this says the set of real numbers is going to be more than this set of integers, rational numbers. Yeah.
So there's more real numbers.
Even
than
just
there are
between
integers.
0 and 1.
Right, there's more real numbers even just between 0 and 1 than there are rational numbers. So if you think of the rational numbers, you're going to think, hey, if I write down all the fractions, like that infinite shark's teeth,
Yeah.
you think I'm going to get everything, right?
Yeah.
But there's
But there's
infinitely many things you miss.
There's not just that.
More infinitely. So, like, somehow more infinitely many
Right.
than what you had before.
Somehow if once you cross out all the rational numbers, what you have left is still even more than the rational numbers.
Somehow larger than...
Okay.
Yeah.
And let me ask you this, just to wrap up. Why does that seem strange?
Well, if you cross off infinitely many things from infinitely many things, you shouldn't have infinitely many things left over.
Okay.
Because you're subtracting an infinite amount
Right.
from infinity.
Uh-huh.
So that sort of supports that there'd be more levels of infinity.
Yep. Well, here's another idea that ought to bother you. If I have a real number here, call it real number 1, and a real number 2, I probably can find a rational number in between them.
Yeah.
So if you pick any two real numbers,
Mm-hmm.
I'm going to be able to do, like some sort of, continued fraction, maybe. I'll just add them together, take the average in the middle, and then do a continued fraction for this. And eventually the continued fraction approximation is going to be good enough that I'll find a rational number in between them.
Yeah.
Okay, so actually we can construct a rational number in between them with continued fractions.
Oh, but you also find infinitely many non-rational numbers.
That's right. I'll find infinitely many, in fact, more than infinitely many
Yeah.
non-rational numbers in between them. But here's the thing. If I take these two real numbers, I'm taking out all the rational numbers. So one of the strange things that's always bothered me about this argument is there's no gaps. It's not like there's a full interval of just real numbers left.
Mm-hmm.
Because you're always cutting away the rational numbers. And so no matter what two real numbers you pick, so even though there's more than countably infinitely many numbers left when you take away all the rational numbers,
There's also...
there's no intervals.
Yeah. So it's just points.
Yeah. It's really weird. It's really quite strange. So anyway, this is a fun. Did you like this book?
Yeah.
Yeah, I think he's a great author. I hope our friends at the American Mathematical Society find ways to make their books a little better printed so they don't fall apart. But it's a fun book. It's fun to play around. All right, good work this morning, guys.